So let's get
Sorry,
started.
everyone.
Okay.
Yes, just before you begin, Telsey, this is recorded. You guys are not obligated to turn on any cameras. Just again, just wanted to warn everyone. Sorry about that. Sorry for the interruption.
No problem. So first order of business, if you just joined the meeting, feel free to fill out the sign-in sheet. And that helps us know if you're interested in the event and we could do more like this. So that's one order of business and I could start right away. So there's a bunch more links in the chat that you might have seen. There's one link that leads to the GitHub page. And the GitHub page is where we push all our code and that's the easiest way to share it. So if you can open that page, that would be really helpful. And if you want to follow along, that's a great way to start. So once you are in the situation, one thing you'll have to do in order to follow along is to open this open collab link. And collab is basically like an online IDE tool that you use to run your code, and it's done all on the internet, so you don't have to worry about having a powerful computer or anything like that. So once you do reach that point, you should be able to see this link, the code right here. But since we're using data, there's always outside resources that we may need. So in this case, where we will have a resource about Netflix. In order to get that Netflix data, you have to go to a website to get the data. And in this situation, I use this Netflix movie data from this website called Kaggle. I know you have to create an account, but once you do, and if you download the file, you're able to see the data with me. And that way we can continue with the code. So if you do want to follow along, I'll wait around like 30 to 40 seconds to set up Code Lab and get ready.
If you guys are having any issues in accessing anything or are having trouble like just with any of the links, please let us know in the chat.
In the meantime, I could also show how to get the data. Once you do get the data, there's another situation or step that you have to do in CodeLab in order to run the data. So that's something that we could do right now. Hopefully everyone is up to speed. If not, this is recorded, so you could also move back or ask questions in the chat. But the way you would open the file was you would get you would go click on this folder, and this folder leads you to the file section. And once you're in the file section, you could easily get the Netflix titles and then bring that over to CodeLab. And I know some people here, they might like to do it on Anaconda. So if it's any IDE, you always need a file path, either through your Mac or your Windows, or in this case, Google Drive. And if you do get the file path, usually you could just right click or click on the three dots and copy the path. And then this really comes in handy once we're extracting the data, and we'll talk about how to get the data out shortly. So let's get started on our workshop. So this workshop is called Cleaning and Visualization Data. So one thing that you have to realize is in the real world, people have a bunch of data they want to analyze or use to help them in some sort of way. But sometimes that data can be messy. There's sometimes problems with the order of the data. Sometimes the data is just wrong. So as a job of a data scientist, you should try to clean the data as much as you can to ensure that it looks great and you can easily get a conclusion out of it. So one way to start by cleaning the data is by using libraries in Python. There's a bunch of documentation and formats that we could use in order to break down the data and learn more about it. And in this situation, we're going to use two things called Pandas and Numpy. So in CodeLab, it should already be downloaded. So one way we could use Pandas and NumPy is by using the import function. So pandas is import, pandas is PD. So that's just syntax that we use in order to use pandas as a way to clean data. And another thing we could use is NumPy, numerical Python. That's what it's short for. And we use NumPy in order to do like math within Python, because Python, doing vanilla Python just without any downloads, can kind of be inefficient. So there's open sources online that you could use to kind of enhance your learning and do everything faster. And these two import Matplotlib and Seaborn. These will be used later on for the visualization part of the workshop. So that's more like making it look cool and ensuring your charts make sense because in order to make charts, it's easier to do it with these two libraries. So let's get started with the data. So once you do import all of these, you could run the code and that will lead you to the next step. And the next step is trying to open the file. And usually we open the file using pandas. We use pandas. And here we just named our file df pandas read.csv. Right now we have a CSV file from this Kaggle link, which we'll use. And in order to open the CSV file, you could easily copy the path of it, or on Mac or Windows, if you go to your file explorer, you could right click on it and there should be an option to copy the file path. And then if you paste the file path, you'll get something like this. So hopefully we run this. It should run. Yeah. So it does run the file. And this thing right now we're just checking to see if the file ran. There should not be any errors. If there are, it's most likely due to the file path. But later on, there's a lot of stuff that we could break down from the data. So I know in this case, there's a CSV, so we could just open it in Excel. But in the real world, sometimes the file can be over a gigabyte long. It could be over 1 million rows. And that's really hard, or it takes too long to open in any other situation. So in Panda, there's a really handy option called df.head parentheses 10. So what this does is it gets the first 10 rows of the data and imports it out in our IDE. That way you could easily load the data without having to hassle with a different website. And usually in the real world in companies, the file is sometimes hard to open. So just opening it through this code df.head can be really helpful. And what this does is once you run it, it shows the first 10 rows. And in this situation, we're working with the data called Netflix data. And in the data, there's a bunch of stuff like the show ID, the type of movie it is, who the directors are, and all sorts of things. There's duration, the ratings. So this will come in handy. And let's say in a hypothetical situation, there's people that want to learn what shows people like and what are the most popular. So if we can our goal is to try to get the data out and try to show like our investors what needs to be done and what needs to be let go of. So that's one handy feature that we can do. And another feature that we could see is the last 10 rows. Sometimes you just want to see the bottom of our file. And usually the bottom of the file is hard to get to if you're in Excel. So just having a code using df.tail and Python can really help. And we decided to do the last 10 values, but you could easily do the last 20 values. Doesn't really matter. You could go in any number you want. So that's one handy feature. So in the last 10 values, we see that the show ID goes all the way down to 8806. So over here, we have about 8,000 files, and we're here to just break it down. Does anyone have any questions so far? If not, feel free to stop me or ask in the chat. We're always here to help. So once we do get all of that, we see the first 10 values and the last 10 values. There's more fun sorts of things you can do. So there's a feature called shape. And what shape does is it kind of tells you how many rows and columns are in the data set. So once you do run this code, it tells us that there's 8,807 rows and 12 columns. It might be flipped up, sorry about that. But yeah, it gives us a great idea of what we're working with. Sometimes this information can tell you if something is wrong or not. Maybe there shouldn't be 12 rows, there should be 10. That's something you could easily look at with the shape value. And then to move on, there is even the column, there's a bunch of labels there. So in this situation, like there's a bunch of columns that they may not fit in this head or tail screen. So what we could do is try to get the list of the columns using list df.columns. And once you run this, there's shows you all the 12 columns that are available. This can come in handy if you want like a certain thing, like we want the duration. We know that it's just called duration. There is no like number next to it or it's all lowercase. That really helps us in the future. And then later on, there's an overview that we could look for, and we could just use the word df.describe. And describe is a really good feature in order to see where your data is in the moment. So we saw before the count is 8,807, so that looks about right from the shape. But we could also see what the mean and the median and standard deviation is. So this is something that'll come in handy in the future. But we just from the describe feature alone, we see that the mean is 2014. So most movies are from like either before 2014 or after. That's more of like the midpoint of where Netflix has their movies available. So that's one conclusion you have already just by using Python. So that comes in handy. And then later on, we could also do an info query, df.info. And what this does is it tells us the types of data that are inside for each row. And this is something that comes in handy in like regular Python as well. We want to know if our number is an object or if it's a character, or in this case, is an integer. So release year is an integer, which makes sense because it's just year is a number. So that comes in handy. And while the rest are all objects, this is probably because there's probably decimal points or there's letters inside the word, inside the column, and we may need to have it in an object form. So this is something to look forward to. And one thing that you should make sure of is, like, let's say the description, it shouldn't be integer. Object would make more sense because there's words involved in sentences. So that's something you could look forward to if you use the info feature. So that's how the data can be interpreted. Now let's go to the cleaning part of it. And if anyone has any questions, feel free to put it in the chat. So in order to clean, we have to worry about outliers, if there's any duplicates, or if there's any empty values. Usually stuff like that can break your data analysis. So you should try your best to kind of break it down and ensure that what you're doing is helpful and it can be easily distinguished. And we could check one feature called duplicated. So in this situation, we write df.duplicated. And then once you run it, it tells us if there's any duplicate values in our column. And right here, we see that there aren't any duplicate values. They're all unique. Every single column has its own unique type of answer. So that's one thing good to know. We don't have to mess around with that. But let's say that you do have a data set that has a bunch of duplicate rows. Well, luckily for you, Pandas has a function called duplicated. So df.duplicated can easily let you know the number of rows that have duplicates. In our situation, we have zero, but in other data sets, it could be over thousands. So you easily get rid of them using the drop feature. So if you do df.drop duplicates, that would just get rid of all the duplicates for a situation because we don't want to have two responses of the same movie because that would just create more problems with our data and our mean and all sorts of things. So that's one thing to get handled. And just to double check, there's another handy feature called unique. And what unique does is it shows you the amount of rows after you get your duplicates out. So for us, it's all the same because we don't have any duplicate files, but you may have. So this is one great tool to get to know that. Next, we have to find out if we have any empty values. Sometimes some shows that they probably don't have a rating or they don't have a release date. So that's one thing that we may want to look at. So in pandas, you would use df.isNull. What this does is it kind of filters out all the rows and see if there's any data in it. And then once you run it, it gives you this chart right here. It may sound confusing at first, but what this basically means is if it says false, there's a words in there. There's a bunch of distinguishable objects. But if it says true, like in line 3 and the director, that means it's empty. And we could double check our data right here. If you go to row 3 and the director and cast, yeah, they're both empty. They're not applicable. So that's something that comes in handy with when you look at is null. And let's say for our situation, we just want to get rid of them. They cause a headache. So let's just get rid of them. So what you could do is just run it be like from before, see which values have null. And what this does is null.sum. It kind of gives you the number of blank columns. So like for directors, there's 2,000 movies without a director, which is which is probably wrong. Most movies have a director involved. So for our situation, let's just remove it for now. Like, we'll worry about that in the future. And we could, yeah. So you could check the chain, the shape, and you could drop all the NAs. So df.drop NA. This should drop all the director and all the empty rows. So it makes our life easier for now. And let's check the shape once more. So after all of these were got rid of, we went down from 8,000 columns to just 5,300. So that's so much data that got cleaned up. So this comes in handy. This will it will change our data a lot. So it's good to have that sorted and fixed. And since we did drop our no values, we always have to double check to make sure that we didn't leave anything behind. And you could do this by checking is no.sum. And right now we have zero no values. So it looks like our code from the above worked. So that's good to hear. And just to make sure that this meeting is being recorded, and we will share this and post this to YouTube if you ever want to review it. Does anyone have any questions? If not, let's just move on. So let's say that you're in another situation where you don't want to drop the feature. Sometimes you may want the empty values in order to kind of understand what went wrong. And so what you could do in that situation is just replace the values using a function called fill.na. In our situation, we don't need to do that, but that's a handy feature that comes in handy with other data sets. And then just to double check, we could see our unique values. And this adds up. We have 5,300 show IDs. So there should be 5,300 columns. So that adds up. And then just one diversity thing we could look at is Netflix shows that there's movies from over 600 countries, even though there aren't 600 countries on the planet Earth. So that's one thing to look forward to when cleaning data. Sometimes the country could be misspelled or the country could be renamed. So that's one thing that we kind of learned from here, and we could kind of adjust it in the future. So maybe since we cleaned up the data, which is the first part of our project, we could kind of compare it and then see how it looks. So in our situation, I want to download a new file called cleaned Netflix data. And here, what this would do is this would create like a new file and compare the before and compare the after of our cleaned up data. Hopefully you guys could, but from Kaggle. And then from the right is what the clean data looks like. The left shows some missing data, like for show ID one, there's a missing cast name, and for show ID four, there's a missing country. So in that situation, we got rid of that, and we could see the results to our right over here. So this will come really in handy whenever you need to kind of compare it visually and instead of doing it in Python. So let's go back to our Google Chrome and collab. And just to double check, we use df.toCSV file because in Pandas it just gives you a number, and from there we could change it to an Excel file, CSV, J, JSON. So there's a bunch of stuff that you could do, and it just comes in handy if you ever need to export the data out and just share that to anyone. And then I just put this function, print function, just to make sure our code is working. Because in this situation, if you don't run this code, you'll never know if it ran or not. So it comes in handy. And our final step for our data is to check if there's any outliers. And with the outliers, you could easily just use df.describe. And what this would do again is show us the count of everything and the mean change. Before it was 2014, now it's 2012. But we don't really see any outliers besides the minimum, which is there's a movie that came out in 1942 that Netflix has. So in our situation, like we don't want to get rid of that movie. And so that outlier is fine for us just because we want to analyze all the movies that we have available data for, even if it's from 100 years ago or so. Does anyone have any questions? So if not, we did all the cleaning part that we can. There's more stuff that we could do, but let's just move on for now and go to the visualization part. So as a data scientist, this is like the part where we're going towards, which is trying to clean the data. But you also have to worry about like your investors or your managers who don't know anything about Python. They just want to see charts and they want to see everything in a fancier way. So you could do that in Python as well. Try to get your charts and visualize the data in a cool way to share with others. So let's start first by doing a box plot. A box plot is something that looks like this in the bottom. It shows you like in this case, we use release year and shows us all the available entries for the release year. So once we do run this box plot command, what it does is it gives us an output of this blue box and a bunch of more data here. And the blue box is where most of the majority 5,000 movies are filled in. That's where Netflix populated the most movies. So it makes sense. If you go to Netflix, it's mainly movies that came out in the last 10 years. You barely see anything that came out from 50 to 100 years ago. So that does add up. So I think that makes sense. If not, we could also do some changes. But this is a great chart to show others just to ensure the variety of Netflix. So you could tell someone, oh, did you know there was a movie from Netflix in the 1970s to 80s? And they'd be like, wow, I didn't know that. So that's something that comes in handy and it's really useful. So let's move on to more visualization. So let's try, in our situation, get the content type and percentage. And just to reiterate, the content type is either movies or TV shows. That's what Netflix offers. And now they offer games, but in this data, let's just stick with movies and TV shows for now. In order to get a pie chart like this, you have to use this function that we imported earlier called Matplotlib. And what that does is that helps you create charts and visualize it in a better way. And we also use Seaborn to help enhance our charts and make it look better. So yeah, that comes in handy. And now we're going to use Matplotlib now. And one we use PLT as like a general function for Matplotlib in order to like abbreviate it. So that's one thing that you should take note of. And in order to get this pie chart, we would kind of label our chart content counts. And what this does is it gets the type of value and then it kind of puts it in a percent form, which is where the times 100 comes in. And then the next line, PLT figure, what that does is it creates the size for our chart. So right now we have it 8 by 6. We could have it 10 by 8. Like there's a bunch of stuff you could do with your chart to just adjust it to your own liking. So that's a fun way to kind of mess with your chart. But later on, what you can do with your chart is kind of make it look like a real pie chart. So there's a content counts, and then we would name the type of kind of chart as pie. And then here is just some formatting that we use for like coloring. Here we use sky blue and light green just to like easily see it. You could easily replace these colors with something else. So that's something you could kind of have fun with on your own time. And if you do run all of these, you should get an empty chart like this. But this doesn't really show you anything or your manager that you're sharing it to. This is kind of like a bunch of gibberish. So what you can do is you could get the title, you could label the y-axis and the x-axis. In this case, we name the title content type. And we don't really need a y-axis since we're using a pie chart. But yeah, so once you do run all of that, you should get an easier view of your chart. So there's 97% for movies and 2% of shows. So this really shows that Netflix focuses on a bunch of movies rather than shows. So that's a great analysis that you could kind of start with. So that's the one handy feature if you use a pie chart. If anyone has any questions, feel free to share them. If not, I'll go on to the next part, which is a bar chart. It's another way to kind of explain to your audience what's going on with their data. So in our bar chart, let's say in a hypothetical situation, we want to know the movies and TV shows by country. I know that the Netflix is covering all movies from all over the world, so we just want to know how they're doing with that. So like before, we name our function country counts, and then use the df function to get the country value from our data. And then from that, we could also like before change our size 10 by 6. So 10 by 6 looks like this, but you could easily change it to like 12 by 8. Like there's so much stuff that you could do. You could make your chart miniature as well. No problem. And like with before, we could also color our chart. I'm obsessed with light blue, so let's just stick with that for now. And we name our kind bar since it's a bar chart. And like before, we always have to label our chart or else it doesn't make sense to share that because no one will understand what you're doing. So in our situation, we use plot.title, plot.x label, and y label, and we just name our axes that way in order to get our chart and show it in a proud way. So once you do run all this, and one important thing you do have to run is pod.show. Where if you don't run show, it kind of like gives you a bunch of stuff like this, which doesn't really help us in our situation. So we just want to see the chart. So pod.show can easily help us do that. And by looking at this chart, there's a bunch of stuff to see. You can see that Netflix has over 1,000 shows when in America, in the United States, and a lot in India. When I was on Netflix, I haven't really seen a lot of Indian movies, but it's nice to show that they're represented here as well. And there's a few more countries here that I could see that they represent. And remember that we saw over 600 countries. Well, maybe if you clean that up, you could kind of get more countries represented here. So that's one thing to look forward to if you're ever continuing on the project. So hopefully you guys understood what a bar chart does. Well, there's a way more it could do with data visualization. Here we have another type of bar chart, but this way it looks much different. So let's break down what we did here. So in our situation, let's say we want to see who our top directors are and whether they should be hired back and make more movies. So just to first start on how to do that, we could name like a column called top directors. You could name this whatever you want, to be honest. That shouldn't really mean much. But we want to take and extract the data from our directors column in our chart. And then once we get the directors, we want the top 10. So we do dot head and then get the top 10. And then like before, you could edit your size using PLT figure fig size. And that comes in handy. Let's say you're trying to put this in like a PowerPoint and the PowerPoint slides are you want to edit it. So let's say this chart looks too big. Let me just make it smaller. Let me do it 8 by 6. Here it is again. Wow. And like with top directors, you also have to kind of color your chart. If it looks all black and white, it's probably not as appealing, whereas a color like green can come in handy in order to see the value better. And then like with any chart, if you don't label it, it means nothing. So either you could easily label your chart with the title, label, the X label, Y label. And then in this case situation, I named the top 10 directors with the most content. And we see that this guy, Raul Campos and Jan Sutter, they both made about 17 movies. So that's a lot of movies that they make. So probably if they made that much, they probably are capable of making more and they're probably doing a good job. So there's more that you could get from this data, but that's one fun thing to kind of extract. And this might be handy if you're talking to investors. Like Raul Campos, he's probably from Latin America. And so maybe you might want to hire him for more movies from that region. So that's something that you could do and pitch to investors. So let's move on from that to another chart called a pair plot. A pair plot is more like a line chart and a bar chart. It kind of gives you like a better example of your slope that comes in handy a lot. So in our situation, we want to see and use a pair plot chart in order to see our release year in like a better way than before. Before we saw our release year through this box plot, but this kind of can sound confusing for some people. So let's just simplify it for everyone's sake. So like before, we would choose the size of our pair plot. In this situation, I use 8 by 6. I could make it like 10 by 8 to make it bigger. Yeah, there's a bunch of stuff. It made it slightly bigger. We could mess around with that. And then let's just name our chart pair plot and then use Seaborn, which is for the coloring, which is what helps us at SNS to get the chart. and we use the pair plot function and try to get our release year and duration from our data. And then we want it in a scattered format just so we could easily find a slope and understand our data that way. And then we would have that for this situation, it might be confusing, but the way the syntax works for a pair plot is you try to get an access and you get a limit. So from our situation, we know that there are movies from early as 1942, but that would look kind of weird and it wouldn't really represent the whole of Netflix's categories. So let's just start from the year 2000. That's a great starting point to see since that's where movies started kicking off for Netflix, and that's when they started existing. So that's obviously when they would try to get the data. And like always, if you do run this vanilla, it wouldn't really show, this doesn't really show you much. It does show you a good amount of information, but we still want to have like our title and have the show function so it just gets rid of all the junk and shows us everything in a more clear way. And that way you could easily just give this chart to your manager, you could save the image, copy it, and then that way it's an easier way to give your analysis and input. Does anyone have any questions with that? If not, there's endless amount of things that you could do, and there's a bunch more stuff to cover, but it would take all day. So let's just move on to other things that we could do with that data instead of cleaning and visualizing. So one thing that you could do is try to get a correlation, kind of predict what happens in the future. You could kind of use this as a way to see where to invest in the future if you need more movies or if you want more TV shows or what type of directors you may need. And one way we could do this is through feature engineering. So this is kind of like a fancy word, but what feature engineering is trying to kind of predict what to do in order to make the example, it's like finding the right ingredients to a recipe. So if you try to collect the correct features and try to get the certain values to your own liking, you try to make, you try to mess around with the data and try to get the right ingredients to make the data more better and more efficient for the future. So all in all, feature engineering is like trying to get the most out of your data and make it look the best as you can or the most ideal you can. And this leads more into the machine learning aspect of it. And the machine learning aspect is more like trying to predict what goes on in the future. And here we could import another library for machine learning that is kind of advanced. We could go more on that in the future called sklearn. And what this would do, it would kind of do the processing and encoders of your data and try to understand it that way. And this may sound confusing at first, so feel free to ask questions. So let's start by getting an encoder. So what an encoder does is we kind of use zeros and ones. So like a zero is something that zeros and ones, they help you kind of understand like the true and false, what can be improved and what shouldn't be improved. And then here we try to encode the type of our movies and the ratings. So that way we could kind of understand the zeros and ones more easier. And it might become clearer later on. So I'll show you how to use the zeros and ones later. So to kind of do feature engineering, you need a correlation. And a correlation matrix here, we would use core.matrix and kind of understand how to use our data. So we would use our encoded data of the type and our encoded data of the ratings, and then try to get a correlation. So once you do run that, Python will kind of mess around with the data for you and understand what's going on. So from later after that, you might want to like visualize the data because this doesn't really tell you anything. You kind of want to see it in a chart. That's the best way to understand something visually. So we could use a heat map. And a heat map, it's kind of what tells us if like the coding is from closer to 0 or 1. And the heat map here, we use our correlation matrix, and it gave us this chart right here, this map. So this may look weird at first, but what this is telling you if the type of encoding is closer to 0 or closer to 1. So in this situation, we saw that the type encoded column is closer to 1. So that can easily be correlated since we have two types. We have TV shows and we have movies. So that makes sense why we would want to correlate the data and try to do more with it. But if you look at the ratings, there's a bunch of ratings involved. There's ratings can be in terms of like 5 star to 10 star. And this really showed us that 0.11 is closer to zero. So it's all over the place. So trying to get a conclusion out of this can be difficult. So it might not tell us much to use rating encoded, but just to use it type encoded. So that's one thing you learn as you go on. So in the real world, maybe you might say type encoded. So we might want to understand more of the types of movies and TV shows. We might want to expand more on that and correlate what we need to work on. So that comes in handy. And yeah, so 0.11 is closer to zero all along. So rating encoded is probably not the ideal situation to use. And there's more things you could do with correlation and machine learning, but that's something for a different topic and we could continue later on in the semester. And yeah, that should be it for everyone. There are endless amount of things that I could do, and hope you enjoyed, and we hope to see you again in future events. And as always, feel free to give any questions.
Yes, thank you so much, Chelsea. So for anyone that still hasn't filled out the sign-in form, please do. It's still attached in the chat. I just recently sent it. Again, thank you so much for coming. Chelsea did an awesome job. To anyone who wants to rewatch this workshop, it's going to be uploaded to YouTube on the AIS channel. Yes, this is all in Python. All the libraries that we pulled are from Python. And just a sneak peek, we are going to be using sklearn for a upcoming workshop we're going to have. You guys are going to the first to hear it. We're going to be doing the decision tree workshop and random forest workshop as well. So this will be very helpful. Yes, we can do a follow-up workshop on feature engineering. That is definitely a big topic and we can definitely explore it. But if you guys don't have any further questions, I think that's it. Just as long as you filled in the sign-in sheet. They're going to be another online meeting soon. Yeah, so we actually are going to have our what's it called? The GIM #2 next week, if I'm not mistaken. Let me just clarify that just to be 100%. That is going to be in person, but we are going to have the Intro to Python workshop. That is also in person. The next online meeting that we are going to have is most likely going to be the decision tree one, which is going to be at the end of March. I will tell you right now exactly. So the GIM 2, which is in person, is going to be on the 14th, as well as the Intro to Python, which is going to be on the 12th. That they are both in person. So for the time being, we don't have any online meetings scheduled, but we will have a couple of them like later on in the semester. Yeah, so for the decision tree and random forest one, the tentative date right now is the 28th. There will be an announcement about the date, time, Zoom link as well. That's gonna be, I believe that's gonna be given out in about a week or two. But again, the tentative date is gonna be the 28th, because that is also gonna be a workshop hosted by the data science committee. Yeah, the Python is hybrid in person Zoom, I think. I'm not sure. Everything is in the announcement for it.
And by announcements, they're all on Discord. So if you do join our server, which you're always welcome to, we always post our things there early and for you to sign up. So hopefully that helps. And then, yeah.
Yeah, and then the interview is still happening for leadership. No, unfortunately, they are not. We have concluded our interviews. If you do wish to be on the board, then you are free to sign up next year because there will be a couple open positions next year. So stay tuned for that. Are we doing workshops? SQL. We are planning to maybe do a SQL workshop next semester, but for this semester, there are no plans to do a SQL workshop. If there is a lot of demand for it, I'm more than happy to do it, but it's most likely going to be next semester. Just with all the workshops that we are planning, it most likely won't fit into the schedule. But if it's something that you really want to see, I would suggest reaching out to us, and it's maybe something that we can work on for the semester. Yeah, of course. Yeah, we're also collabing with Marketers of Baruch for a UI UX event. Again, will be posted in the announcements in Discord, so look out for that. Everything is in Discord. If you have any other questions, feel free to reach out to us either on Discord or on LinkedIn. But if there are no other questions, that's the end of the workshop. Thank you everyone for coming. I really appreciate you all taking time out of your day to come and listen. Thank you to Tausi for an amazing workshop. Yeah. Yeah, of course. I hope everyone has a great day. Thank you for coming. Bye, everyone.
You can stop